Hey guys, it's Mr. Regan. Today we're going to look at solving systems of inequalities by graphing. We've been solving systems of equations, and we had a few different ways to do that, but now we're going to be looking at systems of inequalities. Alright, so let's start off with y is greater than equal, because these are inequalities now, than 2x plus 1, and we'll have y is less than the opposite of x minus 2. Alright, so let's graph our first inequality. Y is greater than or equal to 2x plus 1. So we have a y-intercept at 1. Our slope is 2. Up 2 over 1, up 2 over 1, 2 over 1. Now, it's y is greater than or equal to, so I know that's going to be a solid line. We learned that earlier in the chapter. Greater than, we know that we're shading above the line. Okay, and we also know that if we're not sure, we can always take a point over here in the shaded side and check it by plugging it into the inequality. And now we're going to do y is less than the opposite of x minus 2. The y-intercept is at negative 2. My slope is negative 1. So I'm going to go down 1, over 1, down 1, over 1, down 1, over 1. Could have also gone up 1, left 1, up 1, left 1, up 1, left 1. This is less than, there's no equal to part, so this is going to be a dashed line. And less than means I'm shading below. Alright, now, here's the difference between graphing inequalities and graphing a system of inequalities. We're looking at two shaded regions. What we are looking for is where they overlap in the shaded region. So if you look down in this area, we can see that the shaded regions are overlapping. So I'm actually going to color this in blue just to distinguish it a little bit. And we're looking at something like that. So all of that shaded region would be the solution. So any point in that shaded region would be a solution to this system of inequalities. So it would work in either inequality. Okay, so you could just pick a point in that blue shaded region, plug it into both inequalities, and you could see if it works. So we're going to try one. Let's take, I don't know, 1, 2, 3, 4. Looks like negative 4, negative 2 is in the blue region. So we'll plug it into our first equation. Negative 2 greater than or equal to 2 times negative 4 plus 1. 2 times negative 4 is negative 8. Negative 8 plus 1 is negative 7. And negative 2 is greater than or equal to negative 7. So that's true. All right, now we'll take our second equation, plug our ordered pair into that. So y negative 2 is less than the opposite of x. So the opposite of negative 4 minus 2. Opposite of negative 4 is positive 4. 4 minus 2 is 2. And negative 2 is less than 2. That's true also. So then we did shade the correct region. Now let's try another one. Let's try negative 4x plus 2y less than or equal to negative 6. And let's try 1/3 x plus y is greater than or equal to 1. Alright, so our first equation, it's not in slope-intercept form. So our last example we looked at, both equations were in slope-intercept form. It was easy to do. This one won't be that difficult. Just have to get it into slope-intercept form. So let me add 4x to both sides. I get 2y is less than or equal to 4x minus 6. Divide everything by 2. And y is less than or equal to 2x minus 3. Just outline that. Alright, down here, let's do this one in red. We're going to subtract 1/3 x on both sides. And I'm going to get y is greater than or equal to negative 1/3 x plus 1. Alright, so let's graph. Our first equation, or inequality, y is less than or equal to 2x minus 3, y-intercept at negative 3, a slope of positive 2, so up 2 over 1, up 2 over 1, up 2 over 1. And there's an equal to part, so it's going to be a solid line. Less than, so it means I'm shading down in this region. Alright, let's try our next one. Y is greater than or equal to negative 1/3 x plus 1. Our y-intercept is at positive 1. Our slope is negative 1/3, so down 1, 3 to the right, down 1, 3 to the right, down 1, 3 to the right. This also has an equal to part, so I'm going to draw a solid line. This is greater than, so I'm going to shade above the line. Alright, once again, I'm looking for the shaded region where they overlap, so that looks like it is in this area. Shade that in blue. Now, obviously, if you're doing this with paper and pencil, and you don't have colors, you're just going to shade it so it is darker. Alright, so that's our solution. Anything here in the blue area. And once again, if I wanted to, I could take a point in that blue area, plug the ordered pair into both inequalities, and see if it satisfies both. Alright, let's do one more. Let's try y is less than 4x plus 1. Let's do this in red. Y is greater than negative 1/2 x. And let's do a third. X is less than 3. So now instead of 2 inequalities, we're going to have 3. Alright, so our first inequality we'll do in green. Our y-intercept, or y is less than 4x plus 1. Our y-intercept is 1. Our slope is 4, or 4 over 1. So I rise up 4, I run 1. Rise up 4, run 1. There is no equal to part, so we're looking at a dashed line here. Less than means I'm shading below. Alright, we'll do our next one in red. Y is greater than negative 1/2 x. Has a y-intercept of 0, 0. And our slope negative 1/2, 1 down to the right, 1 down to the right, 1 down to the right, 1 down to the right. Once again, no equal to part, so we're talking about a dashed line. And this was greater than, so we're shading up. So I can see kind of where the overlap is here. But we have one more line. X is less than 3. So now we're looking at a vertical line going through 3 on the x-axis. And there is no equal to part, so once again, this one's going to be dashed. And less than, when it's a vertical line, is to the left. All right, now we got a lot going on here. I'm looking now where all 3 shaded areas come together. So that looks like it's kind of right in here. So I'm going to shade all that in right in there. And there we go. It was to the left of x is less than 3. It was greater than y is greater than negative 1/2 x. And it was less than, so y is less than 4x plus 1. And then that will be our solution. So any point in that blue region, I could plug the ordered pair into any of those inequalities and it would be true. It would work for all three of them. Alright, that is solving systems of inequalities by graphing. Good luck, guys.